5 people are seated on a bench. How many ways can they be seated if there's no restrictions? Not 16. Yeah, so 5 factorial, or there's 5 choices, sorry, 5 decisions. 5, 4, 3, 2, 1. So that would be 120. 5 exclamation mark means this. Okay, so now I have to have A and B sitting together. So we have to pretend A and B are on a big chair. 1, 2, 3. There's the big chair for A and B. Okay? Now picture this. I can move these 4 spaces how many different ways? I'm sorry? Only 4 ways? You should be saying 4 factorial ways. Right? I can move these things 4 factorial ways. It's kind of like moving 5 things. Now I have 4 things. Yes? And then, so when A, B gets moved, does everybody see, like, for instance, this is C, D, E, and this is A, B. And then A, B can move, say, in front or in the middle. We can move it all around. We can also make a different arrangement if we move A, B around and have it as BA. How many ways can that happen? How many ways can I move 2 objects around? 2 factorial ways? Yes? 2 decisions, 2 choices, 1 choice? Yes? Okay, so the way we do this is it's the number of groups. So do you see I have 1, 2, 3, 4? This is the number of groups. Factorial. And then the number of members in each group. The number of members in each group. And that would be factorial. So I don't list 1, 1, 1, 1 factorial. Like, you know what I mean? Because it's not going to change my thing. So technically this would be 4 factorial, 1 factorial, 1 factorial, 1 factorial, 2 factorial. But I'm not writing all the ones. Okay. So how many ways is this? 48. Okay. So how many ways can A and B sit apart? I'm sorry? Okay, so this is what's called a binomial distribution, meaning A and B either sit together or they sit apart. Do you understand that? Like, that's the only thing that can happen in this scenario. Yeah. 120 minus 48 is 72. So it's the total minus them sitting together equals not sitting together. You'll see a lot more of these kind of questions coming up in your homework. How about if A and B sit together and C and D sit together? So we have to group A and B together in a group, and we have to group C and D together in a group, and E is in a group by itself. So how many ways can I do that? Again, we can order the 3 groups 3 factorial ways, and then within the group we can order them 2 factorial, 2 factorial. Very good, we're catching on. So that would be 6 times 4, which is 24. How many ways can 4 married couples sit on a bench if the spouses sit side by side? How many ways can 4 married couples sit on a bench if spouses have to sit side by side? So how many groups would I have? 4. And how many in each group? 2. So 2 factorial, 2 factorial, 2 factorial, 2 factorial, yes? Yeah, because the man and the woman can, or the married couple or whatever, can switch right? The two spouses can switch. So what is that? Somebody needs a calculator for that. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 4, 24. $384. Okay, questions on that one? Okay, a family consisting of a mother, father, and 3 children are seated in a row for a photo. If the parents must sit together, how many arrangements are possible? So how many groups do I have? 4 factorial, 2 factorial, which is what, 24 times 2? 48. Any questions there? These are pretty easy now. Once you know how to do it. How many? Oh, now I'm just throwing stuff at you here. These are, again, the digit questions are the hardest questions, right? How many 4-digit numbers larger than 2300 without repetitions can be made using the digits 0, 1, 2, 3, 7, 8? Well, I'm sure we're going to have more than 2 cases. So what's the next biggest number I can make? Yeah, 2301. And then when would I have to change that case? When would I have to change the next case? Because 23 whatever is going to be automatically bigger, right? So this case could, like, I could change this to a 7 or an 8, and it's all good. There's no restrictions, right? So I'm thinking, and you can correct me if I'm wrong, having a 2, a 3, a 7, or an 8 is the first case. Yes? Does everybody see how I kind of deduced that? Like, there's not really any way that I could not make it bigger starting at 2301. So what would case 2 be? I think we might only need 2 cases, actually. What would the next case be? Yeah, it starts with a 3, 7, or an 8. So yeah, you said it was 2. Okay, so there's only 1, 2. We only have the choice of 3 here. And after I've used up 2 digits, and I have 1, 2, 3, 4, 5, 6 digits total. Yeah, 4 and then 3, very good. Yeah? So that's what? 12 times 3, 36. And then case 2, I have 3 choices here. I've used up one of the 6 digits, so how many do I have left? 5, then 4, then 3. So that's 20 times 9, 180. So my total is 216. Any questions there? Okay, this one's a way harder one because now we have ones that we can make. So, using the digits 1, 3, 5, 6, 7, 9, how many 4-digit numbers are greater than 65, 67? So let's make the first one that's bigger. Okay, so we can't have repetition. So 6, 5, 7, 1 would be the next biggest one. You can't have repetition. Yes? Again, we can't have repetition, so we can't have 2 6s. Yes? Okay, so 6, 5, 7, 1 is the first biggest one. So now, how can we keep that together? Does it matter what the 5 is? Well, because we could have a 30-something and a teen. So our first case has to be 65 and then starting with a 7 or a 9. Does everybody get that the first case, we have to restrict it that much? Case 1, it has to be 65, and then we can either have a 7 or a 9 here. I can't go all the way to the hundreds. Does everybody understand that? Like, I can't just change the 5 and make it a 5, 7, or a 9. Yes? Because in the tens, I could have something end up choosing something lower, right? So I have to restrict it down to the tens. Okay, so now what's the next biggest one after the tens are restricted? You think it's like 6,600, but you can't use the 6 again. So 67. Yeah, say 1,3 or something like that. And you could have a 69 in there as well, right? So case 2 is going to be 6, 7, or a 9. Yes? Okay, so then now we're going to have case 3. It'll be pretty open, right? Case 3, again, when you do cases, you have to describe the cases, and even just putting stuff underneath the blanks is describing it, but you can't just put numbers there and expect to get marks for anything. Okay, so what is case 3 then going to be? Yes, a 7,000 or a 9,000. Okay, so then we have 1, 1, 2. We've used up 3 out of the 6, so we have 3 left, so we have 6. So 1, 2, we've used up 2 of the 6 for 3, so we get 24. We have 2 choices here. We've used up 1 of the 6, so we have 5, 4, 3, yes? So that's what, 20 times 6, 120. So my total will be 150. Same thing though. Okay, so in how many ways can person A walk to person B if the trip takes exactly 6 blocks? What they're trying to say is you can't go back. Like for instance, you can't go this, 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 because now you're going back, because there's no way you'd get it to be in 6 blocks, right? So it has to be a bunch of rights, or a bunch of easts and a bunch of norths, right? There's no way, actually they're doing rights and ups. There's no way you could get here if you don't go 4 rights and 2 ups. Does everybody see that? In order to get it in 6 blocks. There's no other way except you can go up, up, and then right, 4, or you can go up, right, right, up. There's a bunch of different alterations, but it's essentially 4 rights and 2 ups. That's the only way you can do it in 6 blocks, right? Does everybody agree? So essentially, we have a made-up word. And we can do it in any order, right? So, how do we do this then? A lot of these have to do with the way you do words, like the flags. There's a whole bunch of things that you can just, anything that you have repeated things, and it doesn't matter if I switch these 2 R's around, that's that word thing. So, 6 factorial divided by 4 factorial, 2 factorial. Yeah. So 6 times 5 divided by 2. So it'd be 15. Does everybody see how I got 6 times 5? And the 4, 3, 2, 1s cancel?